But let me ask you. In 2020, can you tell us, how do you feel, how do you think people feel, how Japan feel right now?
I mean, the way I feel right now is, just sheer excitement. I'm watching His Excellency Bilhol, the team over there at Tanegashima. I guess you'd say they're over the moon, But I think this is all, the 6 years that the team have been working towards this has just been phenomenal. As you heard, the UAE go out and decide to buy a satellite. Really wanted to make sure this is something where the UAE nationals learn from. We're not just buying something off the shelf. And so the millions of hours that are put into that is just, all coming to this point right now where, information is going to be coming out. And as mentioned, this information is not just arbitrary. This is really information being looked and sought out for in the space community today. I think the teams that were over in Japan, they've been there, as I mentioned, since April. I'm sure they miss their families, but these guys are heroes to us. They're group of 17, been there since April, haven't seen their families, haven't seen their kids, and they've just dedicated their whole time now to making sure the success is there. With the delays that have happened with weather, that's part of the natural launch campaign. All of these things, the engineers look through this, they anticipate these things. We have a window, calculations are pre-calculated on a daily basis, anticipating a disturbance due to the weather or a delay due to that. So from my side, being here at the studio, it's a little different. You don't have the air of the whole team around you, but I know at the UAE Space Agency we have a team over there. They have a gathering put together, and I'm sure they're all celebrating right now as well. And yeah, and the whole team's over at the MBRSC are doing the same.
You mentioned the delay. For us, we were sort of ready to gearing up to go on air. We're very excited about it and gearing up again. We totally understand the situation means that you have to have that delay. I'm thinking the team over there, slightly more cooler, a bit more ready, and actually maybe potentially expecting the delay to have taken place.
Yes, honestly, it was quite funny. It was probably around the 18th. It was actually just the weekend before that I was asked to join the EMM media committee. So, I was mostly working with the project director, Amran Sharaf, every other day or so. I communicate with him, make sure things are going fine, and reporting up. And so, we were pretty much done and ready, and I was asked then to join the media team. And I could sense the excitement, and the positivity and the whole push on that aspect. I was watching the weather all the time and thinking, guys, we need to make sure we're planning as well that, there could be a delay coming up here, and so, like you said, the engineers, it was expected, these things happen, as His Excellency Bilhol mentioned, SpaceX, it was like 10 minutes before a launch, they decided to pull out just because of weather reasons. But luckily, we, MHI, they're the ones who are responsible for this launch. So they're the ones who are overseeing this launch, and they're the ones responsible to get,
لكن بعد مرحلة الإطلاق طبعا عندنا اللي هو الجانب الاتصال الأولي أو انفصال المسبار من صاروخ الإطلاق. هذا بيحدث إن شاء الله حوالي ساعة بعد الإطلاق. عقبها بحوالي 6 دقائق إلى 8 دقائق إن شاء الله بيقوم المسبار بإطلاق ألواح الشمسية، وعقبها إن شاء الله بربع ساعة إلى 20 دقيقة بيكون أول اتصال عن طريق إن شاء الله المحطة الأرضية عندنا في دولة الإمارات. وعقبها إن شاء الله طويل العمر بتبدأ رحلة ال7 شهور اللي بيمر فيها المسبار على أكثر من 490 مليون كيلومتر لما يوصل إن شاء الله الكوكب الأحمر في فبراير 2021 بإذن الله تعالى، واللي تعتبر أيضا أحد أهم المراحل في المشروع اللي هو يسمونه المارس أوربت إنسيرشن، الدخول في مدار المريخ. 30 دقيقة هاي طويل العمر بتكون من أكثر المراحل الحساسة. بنقوم بإنزال سرعة المسبار من 121 ألف كيلومتر في الساعة إلى 18 ألف كيلومتر في الساعة.
مشكور على الجواب يا ولدي، مشكور، الله يحفظك وموفقين إن شاء الله. وهذه فرصة نحن نشوفكم ونفرح وياكم بهذه المناسبة، واللي شرفني فيها أخوي محمد الله يحفظه في دعوتي أني أكون موجود معاكم. موفقين.
يا مرحبا يا طويل العمر، لكن لولا قيادتكم لما صار هذا، وأنا أشكركم على هذه القيادة يا طويل العمر، وأنا أقول لهم كذلك موفقين والله يوفقكم.
Most, into the planet. So it is very different. I read somewhere once that a mission to Mars would probably, I think they said, just to get 400 kilometers away from Earth, probably uses up 80% of the fuel.
Yeah.
So just to get 400 kilometers off the surface of the planet Earth.
Wow.
So less is needed because of the gravity, and then the rest is basically gravity will basically pull you back as well once you get the track and you get moving back here.
Absolutely fascinating. Fahad, stay with us. Please don't go anywhere.
Yes.
Promise. We're going to head over to Faraz Javid. He's over at the Mohammed bin Rashid Space Center. Let's find out what's going on over there. Faraz, can you hear me?
Ray and Yusuf, the excitement is building up over here, and I gotta say it's electric, and why not? Because interplanetary mission, which is all set to take off from the Tanegashima Space Center just about an hour from now. I would say 1 a.m. UA time to be exact. Now, just a couple of things that I would like to remind the viewers is once the rocket takes off is the same place where UAE's first Emirati-built KhalifaSat was launched back in 2018. So it's definitely the second home for some of the engineers out there who are stationed over there for the probe. And of course, when the launch happens, it'll take the launch vehicle approximately 11 minutes and 24 seconds to reach outer atmosphere. Now, this is a very crucial stage for the probe, and I'll tell you why. For two reasons. As soon as the launch vehicle, it's gonna deploy its solar panels, which will power the batteries that will help the probe make the 500 million kilometers journey. Second is establishing the connection over here with the ground team. That is super crucial because this is exactly what is going to allow the ground team over here in Dubai to control the probe. Now, the first connection will be established with a ground station in Madrid. Then they will pass that connection over here at the Mohammed bin Rashid Space Center in Dubai. This is where the mission actually begins. Now, for 24 hours, 7 days a week, for the next 30 days, the team over here, and obviously checking the trajectory, fixing the telemetry that's coming in. Based on that, they will be making all the trajectory corrections and everything. And then after the 30 days is passed, the team over here will be connecting with the probe for about twice a week, and each connection lasts about 6 hours. Now, throughout these connections, it's super important because the team over here will be making sure that the probe is headed towards its right path towards the Martian planet. And of course, let's not forget, cruising at a speed of about 121,000 kilometers per hour. Now, another important factor to be considered in this is the telemetry data. Now, there's going to be a lag based on where the probe is. The lag could be anywhere between 15 minutes to 45 minutes. And based on that, which basically means that by the time the probe actually sends over here, it could take that long and vice versa. So they have built the probe with a fail-safe device. So if it does not receive the right instructions on time, it will hover around at a fail-safe position. And of course, I've got lots more facts to share with you guys throughout the evening, or the early morning rather, throughout this live broadcast. But for now, I'm going to send it back to you guys, Ray and Yusuf, at the studio.
Thank you so much, Faraz. One thing I just wanted to bring up before we go any further is we're talking about a lot of historical firsts this evening. The first Arab interplanetary mission, our first mission to Mars, of course, but we're going to hear the very first countdown to launch in Arabic, and that in itself is going to be an amazing moment.
No, that's for sure. I mean, you see the, Misbar al-Amal, this was not just something for the UAE, His Highness, the leadership, they saw this as something bigger than just the UAE itself. And this was dedicated to the Arab world. And I think that's what made this, so much bigger and so much more exciting, bringing the culture into it, bringing the Arabic side into the countdown. They've done so many different social media events and aspects which have just been phenomenal in that aspect. Just foreigners now, who have done these videos and counting down. And it just sends that message, it's not just to the youth of the UAE, it's to the Emiratis, it's to its residents, it's to the GCC, to the region, and to the whole Arab world.
It sends a message.
It's a huge message. I mean, and just, hope. Why did they call it hope? This was really a part of the whole thing. It's part of the strategy we have at the UAE Space Agency, and part of the strategy that's actually been put in place for the space sector is really to have a project, because that's what brings humanity together. I've heard lots of different astronauts who have come back, and they say that as they start to go further and further, they start to point at, oh, that's my country, and that's my country, and then it's, oh, that's my continent, that's my continent. And then it goes silent, because people realize then, hey, we have one Earth,
Yeah.
There are no borders, there are no lines. And that's what, honestly, I found is really fantastic when coming into this space. I mean, the previous industry that I was in was very secretive in the sense, and it was all very much aligned to country capabilities and all. And coming to the space side, it's been phenomenal, because we pull together academia, we pull together students, professors, industry, scientists from all around the world, and that's just what's made all of this so phenomenal for me just in the last 5 months of being part of all of this.
Absolutely. There's a lot of messages that this mission sends, its completion instead of 6, amongst other things that we'd like to get back to. But right now, we have a very interesting guest with us, ladies and gentlemen, and that guest, of course, is Emirati astronaut Sultan Al Niyadi, and the right man for the right occasion, joining us right now in a video call. A very good day and a good evening to you, Sultan, wherever you are right now, and thank you for joining us. And let's break it with the first question. Last year in Kazakhstan, it was a huge moment when Hazal Mansouri, your colleague, your brother, became the UAE's first astronaut and went to the International Space Station. Now, and we kind of know that at those last 10 seconds at launch, you were concerned for him. How are you feeling now towards a mission that is unmanned, but it carries the hopes and dreams of 7 Emirates and the entire Arab nation?
Well, first of all, good morning, and thank you for having me. So I think in terms of personal feelings, I think it's different. Last time it was a manned mission, so it was a human being on top of the rocket. Now we're talking about a satellite. In terms of the excitement, I think it's kind of similar. It's something new for the whole nation, for the whole region, and we are excited for it. And it will be quite an interesting journey because it will last for 7 months. So I think it's going to be a really exciting 7 months ahead.
Yeah, it's actually going to be a journey for us as well as the probe that gets sent back home to Earth. How important do you see this mission being for the UAE space program, but also for the Arab world as a whole?
Well, it's called Hope Probe. The name was an indication at the time when the Arab world was facing hardships and difficulties. So it's a strong message. Obviously, it's a big milestone for the UAE, and it's a matter of capabilities, developing the technology, and enabling engineers, scientists, and building a platform for this nation and the Arab region.
So part of reaching this historic moment has been the UAE's young people. How can that add up to the UAE's youth, and how can they enrich this program and this mission in the future?
As you may know, that the average age of the engineers in the MBRC are 27 or is 27, and to have these projects inspiring them and build some sort of to look beyond normal. So I think in the future we'll have more exciting projects. Yes, the capability to build satellites, and through good pilots and astronauts, and hopefully this will be sustainable. And now we're sending probes. So it's exciting.
Well, we seem to have a little bit of interference on the line, but we want to keep talking to you, Sultan, because it's so fascinating. You're one of the only people who's actually been through the UAE space program, through training for it. What is it about space exploration that excites you so much?
Well, I don't want to sound cliche by saying it's like a dream since childhood. It is. But in terms of the current science that we should be involved in, it's very exciting to help humanity explore space. It's very exciting to be among the elite club of space. They're less than 600. So to be doing these some sort of exciting job of floating both international exploring space through missions to Mars, I think that is a very exciting thing to do.
Sultan Niyadi, Emirati astronaut, thank you very much for joining us at this moment, at this historical day.
Yeah, we would love to have chatted to you for a little bit longer, just fighting against a bad line there, so sorry about that. Now, anyone who's been following the Emirates Mars mission will know that the launch had to be delayed twice due to unsuitable weather conditions in Japan. Now, fortunately, we had more than one opportunity to get the Hope probe into space. Here's more information about that launch window.
Ground lead and go no go. Mock mom, ground lead and go no go.
Knock mom.
Can you give me the status of L minus 10?
Yes, mock is green.
Mom, ground lead and go no go.
Mom?
Can you give me the status of L minus 10?
We are green. We are working issue with Oasis during a terminating Oasis. That is not preventing us going forward. It is not part of our LCC criteria to quit Oasis. We are fully green to support launch.
Copy.
All stations, LVM on the go no go channel. We will start now the T minus 10 minute poll. I will conduct a roll call now. AIT. Copy, thanks. Ground lead.
Present.
Copy, thanks. And EMM project director.
Present.
Copy, thanks. AIT, what's the space status?
AIT reports the EMM space segment is green at the final launch ball. All Amal is ready for flight. Godspeed.
Copy, thanks. Ground lead, what's the ground segment status for poll number 4?
Ground segment is ready and green.
Copy, thanks. EMM project director, as you heard, EMM Al-Amal is ready for launch. We report green and we are asking you for your final decision.
EMM is go for launch.
Copy, thanks. We'll report to MHI and inform you later. Thanks. All stations in the M1 Gonna Go channel. MHI just reported their T minus 10-minute fall as go. EMM as go.
قائد المهمة إلى جميع المبار جاهز للإطلاق.
لا خليني صار مصر بس انا صرت قبل ايمان لما نسينا نشوف نهاية المكان فرحنا المكان ده يصير متعب خاصة الطيارة
الشاشة هذه شوي متخرجة يعني 3 سكند أو 20 هذا 20 بس الساعة احنا بنرجع الساعة مو بنرجع فبنخلص قبل ما
والله هاي اللي هي هاي هم
370 360
打ち上げ6分前です。現在車上の天候は晴れ、気温摂氏 27.3 度、南南西の風毎秒 7.1 メートルです。H-IIA ロケット42号機の打ち上げに問題はありません。
It's 6 minutes to launch. The current weather here at the launch site is clear. Temperature is 27.3 degrees Celsius. Wind is 7.1 meters per second from the south-southwest. The weather has no constraint for launch.
本日の打ち上げ予定時刻は日本時間の午前6時58分14秒です。
Today's scheduled liftoff time is 6:58:14 a.m. Japan Standard Time.
310、309、308、307、306、305、304、303、302、301、300。
打ち上げ5分前です。
It's 5 minutes to launch.
290、89、88、87、86、85、84、83、82、81、280、79、78、77、76、75、74、73、
自動カウントダウンシーケンス開始。
Automatic countdown sequence has been initiated.
種子島宇宙センター高崎総合司令塔から H-IIA ロケット42号機の打ち上げ状況をお伝えしております。
This is a live launch coverage of the H-IIA number 42 launch from Taksaki Range Control Center, the JAXA 種子島 Space Center.
現在ロケットの管制は吉野発射管制塔から行われています。
The Yoshino Block House is now commanding operations control of the launch vehicle.
43、42、41、240、39、38、37、36、35、34、33、32、31、230。220。210。200。190、89、88、87、86、85、84、83、82、81、180。
打ち上げ3分前です。
3 minutes to launch.
全システムの電源が外部から内部に切り替えられました。
The power has been switched to the internal system.
170。
1段液体水素系準備完了。
We have completed the pressurization of the liquid hydrogen system. It's its first stage.
150。140、39、38、37、36、35、34、33、32、31、130、29、28、27、26、25、24、23、22、21、120、19、18、17、16、15、14、13、12、11、110、109、108、107、106、105、104、103、102、101、100、99、98、97、96、95、94、93、92、91、90、89、
2段液体酸素系液体水素系準備完了。
Pressurization of the liquid oxygen and hydrogen system. The second stage are complete.
79、78、77、
トーチ点火。
We are uniting the torch to power the excess hydrogen.
フレームデフレクター冷却開始。
Cooling initiates at the flame deflector at the launch deck.
65、64、63、62、61、60、59、
打ち上げ1分前です。
It's 1 minute to launch.
55、54、53、52、51、50、49、48、47、46、45、44、43、42、41、40、39、38、37、36、35、34、33、
ウォーターカーテン散水開始。
At the launch deck, the sound separation water system has been activated.
26、25、24、23、22、21、20、19、18、17、16、
フライトモードオン。
Flight mode on.
非常用電池起動。
Activating the thermal batteries.
全システム準備完了。
All systems are go.
5、4、3、
メインエンジンスタート。
We have main engine ignition.
SRB 点火。リフトオフ。
SRB ignition and liftoff.
H-IIA ロケット42号機は2020年1月20日午前6時58分14秒に種子島宇宙センターから打ち上げられました。
We have a liftoff with H-IIA vehicle number 42 from the JAXA Convention Space Center at 6:58:14 a.m. on July 20, 2020 Japan Standard Time.
打ち上げ以降、ロケットの管制は西延発射管制塔から竹崎総合司令塔に引き継がれています。
Following liftoff, the operation control of the launch vehicle has been switched from the block house to the launch control center.
50。
ロケットは現在徐々に東方向の太平洋上へ飛行しています。
The H-IIA is now flying above Pacific Ocean to the east.
60
ロケットは正常に飛行中であり、種子島の地上局は正常にロケットの追尾を行っています。
The H-IIA flight is on course, and the Taneshima station is tracking the launch vehicle very well.
80、81、82、83、84、85、86、87、88、89、90。
SLBA 燃焼終了。
The SLBs have burned out.
100、110、
SRBA 分離。
SLBA separation.
14、15、16、17、18、19、120。
第1段エンジンの燃焼は正常。制御系飛行経路も正常です。ロケットは順調に飛行を続けており、現在の高度は約 95km、秒速約 1.5km です。
The combustion in the first stage engine, attitude control, and trajectory are all nominal. The H-IIA flight is on course. Current altitude is about 95 km, rest is approximately 1.5 km per sec.
衛星フェアリング分離。
The payload fairing jettisoned.
打ち上げ後5分が経過しました。
It's 5 minutes into flight.
ロケットは順調に飛行を続けており、現在の高度は約 170km、秒速約 3km です。
The combustion of the first stage engine, attitude control, and trajectory are all nominal. The H-IIA flight is on course. The current altitude is about 170 km, rest is approximately 3 km per sec.
110、
第1段エンジン燃焼停止。
The first stage engine cut off.
第1弾第2弾ロケット分離。
Separation of the first and second stages.
第2弾エンジン第1回燃焼開始。
Starting the second stage engine ignition for the first time.
ロケットは現在安定して飛行を続けています。
The status of the H-IIA is nominal.
打ち上げ後9分が経過しました。
It's 9 minutes into flight.
第2段エンジンの燃焼は正常、制御系飛行経路も正常であり、ロケットは現在安定した飛行を続けております。現在の高度は約 250km、秒速約 6.3km です。
The combustion on the second stage engine, attitude control, and trajectory are all nominal. The H-IIA flight is on course. Current altitude is about 250 km. Velocity is approximately 6.3 km per sec.
ロケットは順調に飛行しております。ロケットは種子島内之浦の各地上局からの捕捉範囲を離れ、小笠原局から追尾されています。
The H-IIA is in good shape. The launch vehicle has flown beyond the range of the JAXA Tanegashima and Uchinoro stations and into the Ogasawara station.
第2段エンジン燃焼停止。
The second stage engine cut off.
ロ ケットはこのまま完成飛行を続け、まもなく小笠原局の補足範囲を離れます。
We are at the coast phase now. The launch vehicle is shortly flying beyond the range of the Ogasawara station.
この後、打ち上げから約56分後に UAE 火星探査機ホープの分離を予定しています。次のイベントまで一旦実況放送を中断いたします。
Separation of the Emirates Mars mission Hope probe will occur in about 56 minutes into launch. Until the next major event, there will be an intermission.
竹崎総合司令塔からの実況放送は午前7時43分頃に再開を予定しております。
This live coverage will resume at 7:43 a.m. Japan Standard Time.
ここで火星探査計画についての映像をご覧ください。
The Emirates Mars mission is an inspiring project for us. We use this project to inspire our young people, especially people in the region. Through this project, we learned a lot. We gained confidence. We engaged with the international space community, especially in space. Will be shared with more than 200 institutions and universities across the world. This is UAE gift to the world. We are proud to work closely with our strategic partners, especially here in Japan, JAXA, H-IIA. We will celebrate together the successful launch of our Hope probe to Mars. Thank you.
The Emirates Mars mission had a lot of challenges since the day it was announced till today. There are technical challenges, but there are also certain administrative challenges. When you look at the time frame that was set for the mission, it was very, very challenging. 6 years compared to other nations that have 10 to 12 years to deliver such missions. The other challenge that we had was the launch. We have to launch in summer 2020 if we want to reach Mars before the 2nd of December 2021. Any mistake, any delay in the launch, we'll have to wait for 2 years. The other challenge that we have also is the cruise phase, in which we transfer the spacecraft from Earth to Mars in a 7-month journey. Any mistake happens during that phase, we lose our mission. And then when we reach Mars, there's another challenge. It's the Mars orbit insertion, in which we have to slow down the spacecraft from 121,000 kilometers per hour down to 18,000 kilometers per hour. We go too slow, we crash on Mars. We go too fast, we skip Mars, and we lose our mission. Once we succeed in reaching Mars's orbit, we'll have to transfer from capture orbit to the science orbit. That by itself is a challenge. And then we'll have to collect data, analyze the data, and come up with new findings about Mars, and announce it by the 2nd of December 2021.
The Emirates Mars mission is the message of hope to the Arab youth. If a young nation like the UAE is able to reach Mars in less than 50 years, then we can do much more as a region. The same way we used to generate knowledge in the past, we can generate knowledge today and in the future to serve humanity.
この後は三菱重工業製作の映像をご覧ください。
In the infinite beauty of the universe. Satellites, space probes, the International Space Station. Even at this moment, various spacecraft are contributing to our daily lives, and they are able to do so only with the forceful guidance provided by rockets. The body of a rocket is made of very thin sheets, only 17 millimeters thick. To reach outer space, the body must be light yet sturdy. The sheets are cut into a special shape called an isogrid structure, approximately 2 millimeters thick. This makes the body lighter and stronger at the same time. Next, the sheets are combined to form a cylinder. This becomes the rocket's fuel tank. Rockets, shaped like a long and narrow pencil, are mainly composed of fuel tanks. The fuel tanks are used for two kinds of fuel, liquid hydrogen and liquid oxygen, each contained in separate tanks. In order to reach higher speeds, the rocket is designed with two engine stages, each having two separate tanks. requires the engine to be able to withstand extreme temperature.
Few technologies have impacted manufacturing as rapidly and broadly as 3D printing. Since its debut in the early 1980s, the global market for 3D printing has grown exponentially. Also known today as additive manufacturing, 3D printing can work with a broad range of materials. And 3D printers can produce just about anything you can imagine, from a guitar to a human heart, to even parts for a rocket. Japan is applying this amazing technology to producing parts for the H-3 rocket, the country's next-generation launch vehicle. In order to achieve increased payload capacity and shorter lead times to launch, the H-3 actually has fewer components than its predecessor, the H-IIA. The development and application of 3D printing technology at the manufacturing facility of Mitsubishi Heavy Industries, or MHI, helped make this possible. In the manufacturing process, powdered metal alloy is spread onto the printer's platform and is fused by a laser. The process repeats until the part is completed. 3D printing is more flexible than traditional processing methods. It supports creativity and is ideal for originally crafted precision parts. And 3D printers are space and cost efficient and can significantly help reduce material waste compared to other manufacturing techniques like cutting and grinding. Now, MHI Group has applied its advanced capabilities to the development of its own 3D printing technology. Lambda, developed by MHI Machine Tool, is a direct energy deposition additive manufacturing system that features two world firsts: a monitoring feedback function enabling real-time control, and a local shield function to allow the use of a wider range of materials. The same technology will allow Lambda to work on precision parts that are not only made of unique materials, but are also much larger than what other printers are capable of handling, often required by the aerospace sector. 3D printing's rapid transition from curiosity to powerhouse technology has revolutionized manufacturing and made the future more exciting than ever before.
After assembly, the rocket is transported to the launch site in Tanegashima, located in southern Japan.
Partnerships are key to the fourth industrial revolution. Companies are collaborating to develop the advanced technologies and solutions society needs. These innovations generate new streams of profit and make a sustainable impact on local communities around the world. They bring dreams to life. Brescia, a town with 3,200 years of history, is located in Italy's industrial center. Here, local steelmaker Ori Martin partnered with energy technology company Turboden to install a plant that recycles the steel mill's waste heat into electricity. The process also cuts the mill's CO2 emissions and benefits the bottom line, a dream combination that many energy-intensive industries can apply.
We invested a lot in the last year, especially to reduce noise, to reduce pollution, to reduce emission, and one of the most important projects we had is a recovery project.
Turboden's organic Rankine cycle technology, which generates the electricity, is at the heart of the project.
Most of the projects that we implement are based on a strong relation between our company, the customer, and other technological providers that complement our solution. And the Ori Martin project is a clear example of this.
Thanks to this plan, we can recover the hot fumes from the electrical arc furnace and convert them into energy. We can produce electrical energy compared to the consumption of 700 families.
Half a world away is a family-owned business in the American heartland. Steer Enterprises is a long-time part supplier to global automakers. The dreams and hard work on which the founder built the business 3 generations ago live on in quality partnerships today. The company chose Mitsubishi Caterpillar Forklift America to provide a fleet of forklifts to optimize its operations.
We always say that we're building our company for generations to come, so our decision making, whether it be purchasing a forklift, purchasing a business line, all of those are thinking 10, 20, 30 years out.
The long-term view is even more crucial in projects outside of the planet. Space has always been a dream destination for humankind, and Japan's new rocket aims to make it even more accessible. The Japan Aerospace Exploration Agency and Mitsubishi Heavy Industries are decades-long partners and are now working together on the H-3, Japan's next-generation rocket. Scheduled to debut in 2020, the H-3 will slash launch preparation lead time and price and build on Japan's world-class launch success rate.
まずこの H-3 ロケットの目的が
The objective of the H-3 is to lower the barriers to space development and utilization. It's very important to make space easier to access for humankind, and we need to make sure Japan always has a means to access space. By making the H-3 rocket less expensive than its predecessors, we aim to reduce the cost of going to space. This will spark robust space development and utilization.
That's a big dream, one that cannot be achieved alone. Engineering partnerships. This is what it takes to move the world forward.
Half a day before the launch, the rocket is transported by a special vehicle to the launch pad, entering final preparations for the countdown to liftoff.
Upgrade. 6、5、
メインエンジン着火。
3、2、1。
リフトオフ。
Approximately 2 minutes after liftoff, solid rocket boosters are jettisoned. About 7 minutes after liftoff, the first stage rocket engine will be jettisoned. From that point, the second stage engine fires. The rocket, now lighter, accelerates its speed in zero-gravity space, ready to release the satellite to the designated orbit. The speed required to place a satellite into orbit is about 8 kilometers per second. At this point, the rocket would only need 1 minute to cover the same distance as a Japanese bullet train could in 3 hours. After the satellite is separated, the rocket's mission is completed. The rocket, taking over a year and a half to manufacture, finishes its short lifetime at 30 minutes after liftoff. Rockets are continually evolving. In anticipation of an ever-evolving state of rocket development, Mitsubishi Heavy Industries is developing its next-generation rocket. With decades worth of technologies and expertise, Mitsubishi Heavy Industries will continue to contribute to humanity through the utilization of space.
When it comes to society's biggest challenges, there are no easy solutions. That's why at MHI Group, we address big issues with the power of global integrated engineering and relentlessly pursue incremental advancement. To take on the growing demand for clean energy, we're pioneering alternative energy sources and cutting emissions from existing ones. We're anticipating the needs of rapidly growing cities through advancements in transportation and sustainability. Our innovations are revolutionizing how goods get to people around the world through digital warehouses and automation technology. We're making it possible for more people to experience the benefits of space technology with our next-gen launch vehicle. And we're building connections to more destinations with a regional jet that offers more space and comfort for passengers. The biggest challenges inspire our greatest innovations. And because we're constantly working to improve, our best never stays our best for long. So there are always even better things ahead.
ではここでロケット搭載カメラの映像をお送りいたします。まもなく RCC の実況が中継される模様です。RCC 実況にバトンタッチしますので、どうぞご覧ください。
種子島宇宙センター竹崎総合司令塔から H-IIA ロケット42号機の打ち上げ実況放送を再開します。
coverage of H-IIA number 42. Japan Standard Time today from International Space Center. The H-IIA number 42 was launched with encapsulating the Emirates Mars mission HOP probe.
飛行を続けています。
We have restarted tracking the launch vehicle. The launch vehicle is currently in a coastal state.
まもなく第2段エンジン第2回燃焼開始を予定しております。
We are shortly going through another ignition of the second stage engine.
第2段エンジン第2回燃焼開始。
Starting the second stage engine ignition for the second time.
第2段エンジン第2回燃焼停止。
Second stage engine cut off.
Hope 分離。
The hope separation.
ホープは予定された
عملية انفصال المسبار من صاروخ الإطلاق النجاح.
معدل جامعة ليفل اللي يدخلون فيها كم